Okay, they all okay. So let's continue a little bit more about the soil stresses. Okay, in the previous video, we know that effective stress formula is the stress prime equal to stress total minus the pore water pressure. So basically, the Tazagi, researcher of soil, in early of our 19th century, he assumed actually, yeah, he do the experimental results, and he assumed that it is much more easier to define the effective stress in soil so that we can minus the total stress from the pore water pressure. So why? Because effective stress is really important, as we can really observe the real strength of the soil only, not included any water that usually absorbed together with the soil. So effective stress, stress prime, stress total comes from the any gamma, either gamma bulk, gamma saturated, or gamma dry, and minus the pore water pressure. So sometimes it can also easily calculated. So minus the unit weight gamma first, either gamma bulk or gamma saturated, minus the gamma water 9.81 or 10 kilonewton per meter cube, times the depth or the height of the soil, so we can get the gamma prime times the z. So we can get the effective stress, the real strength of the soil. Okay, let's see the example number 2. So we can see here H1 of the soil, first part of the soil, 2 meters, followed by the groundwater table at the depth of 2 meters, and then followed by another 2.5 meters of the similar soil sample. And the second type of soil is having a depth of 4.5 meters. So the first one is sand, and saturated value under the groundwater table is gamma saturated. So gamma saturated is 18, and the upper region of the sand is 13.1. The gamma dry is 13.1. And for the gamma saturated, because clay also lies below the groundwater table, the blue line is groundwater table. So gamma saturated also equal to 19.8. So how we want to calculate the stress at X? Stress at X. Okay. Okay, so let's do this example number 2. Okay, just now you still remember that. Okay, you still remember that we have uh, two round. We have a ground, this ground, and second layer, and also third layer. And in the at some distance, so we have a groundwater table. Okay. So let's see the height. For this one is 4.5. 4.5 meter. Okay, we know that this is gamma dry, 13.1, gamma saturated 18. Okay. And also another gamma separated, if I'm not mistaken, 19. Okay, so let's continue to calculate. So usually in a piece of paper, I usually calculate immediately beside the sketching. Okay. So let's say ini pilih color light sikit, sorry. Okay, actually we want to plot the stress diagram. So either we can easily start the line for the stress diagram, and we can combine together to get the stress total, or we want to separate. Either we want to combine to immediately get the effective stress, or we want to do it separately. Stress total first, uh, maybe the pore pressure first, and then after that we minus the total stress and pore pressure to get the effective stress. So usually for the beginner, I suggest to do it separately, one by one. Calculation first for the stress total. So stress total, if you still remember, gamma times Z, and this one is gamma W, also times Z, and this one is stress total minus U. Okay, so we have three different parts. Okay, let's say assume this is a straight line. Okay, so okay, first we start to have a notation. So this ground surface is a A. Ground surface is A, and this level note as a B. This one note as C. This one either you want to follow the question or you just want to label D. But the interested stress that we want is any stresses that we obtain from this line, this level. Okay, so let's try calculate for A. So it is actually 13. For A is 0. Okay. So do a triangle. So this is uh, stress at B. So it is 13 times 2. So we get the value. If we go down, we also have any next value, which is the stress at B plus 18 times the 2.5, which is we got the stress at C. And next, total stress, and next for D, so now we get stress D equal stress C plus the 19.8 times 4.5. So we get the total. Okay. Similarly, okay, let's try to calculate the groundwater table. So at the groundwater table, the pressure is 0. The pressure is 0. Okay. So this one is 0. Okay, nak beza sikit. And then below is 9.1 times the 2.5. So this is U at B. And how about pore pressure at C? Okay. This is U at C actually. So how about pore pressure at D? So pore pressure at D is U sub D equal to 9.18 times 2.5 plus 4.5. Okay, so that's the answer. Okay, so Let's say this is x1 and x2. So for the effective stress at D, effective stress at D is x1 minus x2. x1 minus x2. Or you can also do a calculation from level to level. So it means this is 0. This is equal similar to the stress total B. This is stress total C minus the UC for pressure C, and this is stress total at D minus the UD. So you get the effective stress D. So that's one approach that you can use to calculate the stress at D. Or easily, if you have a much more good understanding, so easily you can calculate effective stress at D is the 13.1 times 2 plus 18 minus 9.1 2.5 a bit plus the 19 gamma saturated minus the gamma water times the 4.5. Okay. So you can also get a similar answer like x1 and this x1 minus the x2. Okay, so that's for example number 2. Alright, so we can check the answers here in the next slide. So minus 2 meter is here is the depth. Minus mean the deeper we go. So we can see at A, B, C, and D. So the total effective stress at D is 19.3 kilopascal. Kilopascal is similar to kilonewton per meter cube. Kilopascal unit also means kilonewton per meter square. Sorry, kilonewton per meter square. Kuasa 2 Alright, okay, so example number 3, so you can try for yourself. So try later for yourself, and you can check also the answers later. And if you have any question regarding this vertical stress, so this is actually a simple parts of the vertical stress. After this, I will introduce to you different methods such as feather methods, 2-to-1 methods, bulk methods, and so on to help us identify the vertical stress easily when we become engineers later. So that's all for this video. Until we meet again next time. Assalamualaikum warahmatullahi wabarakatuh.